Hi everyone. Today you're going to finish up your combining like term notes. So before we begin, let's take a quick look at what was covered yesterday. So yesterday we really hit hard on the vocabulary, reviewed variable, coefficient, constant. Our new vocab word was a term, and we identified all of those vocabulary words within our expression. After we finished that activity, we moved on to having some practice identifying how many terms, how many coefficients, constants, variables, and using our colored pens to make sure that we identify all of our parts. So those would have been our terms. Let me just do this real quickly so that you can see the colors. Our coefficients were the numbers that are attached to the variable. Don't forget the plus and minus sign that's in front, or positive, negative. The next thing was our constants, which are numbers that do not have variables. They stand alone. They're all by themselves. And then the last thing was our variables. And variables are your letters that represent an unknown number. All right, so you worked through the other two on your own. Here are the answers if you did not get a chance to check them, so you can see if you're on the right track. All right, the second thing that you were told to do before you got to this video was to complete the backside. So if you have already done this, great. I'm going to show you the answers in just a few seconds. If you haven't done this, please stop the video right now and then do this section on your own to make sure that you understand this material and the vocabulary before you check your answers over. Okay, so now's the time to pause if you need to. All right, now here's the answers. So here are the answers. I did not use a variety of colors in this, but hopefully you're still using your colors during this part to make sure you're able to identify all of your pieces. If you have any questions, please make sure that you ask and bring them to my attention, and I can help clarify for you. All right, some of you got to this part yesterday, and some of you did not. So if you did not, start following along now. Those of you who did, you can fast forward a little bit to where we left off in class. So the next thing we're doing is we're going to show how to combine like terms and how you can only combine things that go together. So for example, in this first problem here, we see 3 apples. Yep, the computer kind of messed up a little bit, so please make sure you just change your symbols around. There should be a plus sign there. We have 3 apples plus 1 apple. Can we combine them together? Yeah, you wouldn't go, well, I have 3 apples and I have 1 apple. No, you would say, I have 4 apples. So we can combine our apples together to say I have 4. But if I look at this problem here, which is kind of messed up, so there's your signs. Should be a plus, and an equal. I have a triangle, I have a heart, and I have an apple. Well, can I say I have 3 triangles, or 3 hearts, or 3 apples? Or can I say I have a triangle heart apple? No, you can't. That doesn't make any sense. So in this one, you really can't combine any of them because none of them are the same. None of them are alike. So you would actually have to say, I have 1 triangle, I have 1 heart, and I have 1 apple. There is nothing else you can do to combine those. So if you look at the next couple examples, what can I combine? Well, if I just want to know cats, can I combine the 2 cats and the 3 cats together? Of course, that would be 5 cats. Can I combine 3 cats and 5 dogs? How many dogs would I have? Well, I don't really care about the cats. I only care about dogs. So in this case, I only have 5 dogs. And I can't have 8 cat dogs. That doesn't make any sense. So making sure that I'm only identifying and combining what I have. If I can't combine it, then I leave it alone. 2 cars and 4 cars, cars and cars, I can combine. Dimes and pennies, can't combine those. 2 totally different things. I just want to know dimes, 7 dimes. So that's kind of what like terms are like. You can only combine things that go together that are the same. So what are like terms when it comes to actual numbers? So down here, it says, what is a like term? There's our vocabulary. Make sure you box it. So these are the 2 things that you look for when you're combining like terms. Number 1, do they have the same variable? So x goes with other x's, y's go with other y's, and the same exponent. So x squares go with x squares, y squares go with y squares. So if you look at the example down below, you can see that I have an x squared here and an x squared there, and I can actually combine those. They would be considered like terms, and I'm going to show you real soon how to combine. If I look at these other two, I have an x, I have a positive 3x and a negative 2x. I can combine my x's. They have the same variable, and the exponent would be 1, so I could actually combine those two also. The constant is all by itself, so I can't combine it because there's no other constants to combine it with. And the very last thing in your notes here is just to remind yourself, if you ever see a letter, a variable, and there's no number in front of it, there is always the number 1. Always a good habit to get into, putting those in, especially when you're combining like terms. All right, next page. At the very top, just a little review. Identify what your like terms are. We're going to decide whether the terms are positive or negative. Then we're going to add or subtract those terms to get our simplified expression, because that's our point. We want to take something big, a big expression, and we want to make it condensed, compacted. So in the first problem here, take your first colored pencil, and we're going to put a box around the very first term. If you still need help dividing your terms, feel free to take your pen and go through and start off by dividing all of your terms. So that way you know what you're looking at. So the first one is the 11. 11 is a constant. Are there any other constants? Looking at each term, any other constants? There's a constant right there. Put a box around it. And then over here, we're going to make a little box also. We're going to put all the like terms in a box together. So I'm going to put this 11 is actually positive. And then I have a negative 4. So there's that step. I have a positive, I have a negative, add or subtract, different sign subtract, 11 minus 4 gives me a positive 7. So now I combine those two terms to one term. Switch your colors, and now put a box around the second term, or whatever the next term is that does not have a box around it. And I have a positive 6x. X's can go only with other x's. So as I look through here, that's an x squared. Nope, can't put them together. Next one, there's an x. Uh-oh, but there's no number in front of it. How do I know what to put in the box? Yep, there's a secret 1 there, hidden 1, put it in there, and that's an x squared. So make a second box, and we'll put a plus 6x, and we'll put a minus 1x. 6 minus 1 leaves me with a positive 5x. If they're positive, still put the positive sign in there. It'll help when we put them all back together in the end. All right, and switch over to your next color, because I still see some things that aren't boxed. You keep going until you have no more numbers to box. So in this one, now I'm going to box that x squared, and I'm going to put that hidden 1 back in the problem. And then here is a plus 3x squared. Make my third box over here, and I'm going to put a negative 1x squared in that box and a positive 3x squared in the box. So negative 1 plus 3 is a positive 2x squared. All right, so now I've done everything I can to simplify this problem. So now I'm just going to write it and put it all together. And I usually start with the highest degree of exponent in alphabetical order. So the first one I have x's, and I have an x squared. So I'm going to put plus 2x squared. I have no other exponents, so I'm going to go with the x plus 5x, and then always end with your constant. And this would be a simplified expression that we now are ready to take to the next level. All right, let's do the next one. All right, pick your first color. Separate your terms, if that still helps you. So you always separate right before every plus or minus sign. So there's my terms. All right, and here we go. So the first one is a negative 2x squared. Are there any other x squares? No, 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 and yes. Draw your box. And then I have negative 2x squared and negative 3x squared. Same signs add. So negative 2 and negative 3 would leave me with negative 5x squared. and I'm done. I combined that. Okay, pick your marker or color. Next color, I have a +5. That is a constant. Any other constants? Nope, that has an X in it. This one. Okay, +1. And keep going. And there's a +7. Make your box. And then I'm going to put my +5. I'm going to put my +1. And I'm going to put my +7. And you add those all together. And that gives me +13. If you need a calculator to help you with your energy rules, go ahead. But once you have them in here, you don't need a calculator. It makes it go so much faster. So keep working on those energy rules. Okay, change over. It looks like we still have one that's not boxed, and it looks like it's all by itself. So I can put that in a box all by itself. And there's really nothing I can combine. It's all by itself, so I just bring it down. Now I have my 3 terms, which I'm left with. So I went from 1, 2, 3, 4, 5, 6 terms down to 3. So we went from here to here. So let's put it in order with exponents first, -5x squared. Then I'm going to jump over here to the coefficient, 4x minus 4x, and finish with my constant, +13. When you are writing your final product, please make sure between every single term there's a plus or a minus sign. And that's why it's a good idea to make sure you always put the plus and minus so that you don't eliminate that. All right, last one, and then you can do the you try on your own. So we're going to separate, 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 separate. A lot of terms in this one. All right, here we go. Pick your color. 3x. Oh, ladies and gentlemen, if you feel like pausing before, maybe you want to pause right now, try it, and then see if your answer matches my answer. This would be a great time to do that to make sure you're on the right track. All right, so you had a chance to pause if you wanted to try this one on your own. All right, so here we go. You should have done 3x, and that should have gone with the +4x. So over here, a +3x, a +4x gives me a +7x. Keep going. Lots of colors to play with. Here we go. The next one is a -5y. I look for any other y's. Here's a y right here. It's kind of like a matching game. Kind of fun. -5y and +8y, which gives me different signs subtract. +3y. Change again. I have a negative or positive x squared. I'm going to throw my 1 in there. There's that hidden 1. And here's another negative x squared. So that'll be a -1. Make my boxes. I have a positive 1x squared and a -1x squared. Well, those cancel out to 0. So I won't have any x squares in my final answer. And then the last one, I'm left with my constant, -2, all by itself. All right, so when I put this one all together, I don't have any exponents, so I'm going to start in alphabetical order, +7x, +3y. Because this is 0, I don't have to put a 0 on because it's +0. Don't need that. So drop that and just go -2. And there it is in simplified because the x square is completely canceled out. All right, so that is how to combine like terms. Your task is to complete these last 6 problems in your notes. Get these done, then you are finished for the day. You can work on other homework. Definitely go on and work on volume review. There are some interactive sites you can do to practice that also to get yourself ready for the quiz next week. All right, I will see you guys later. Bye-bye.